G'day guys, and welcome back to my lab and to our series on creating a Zelda-like top-down ARPG in Godot 4. Last lesson we called it Zero to Zelda, which I thought was a great alliterative title, but because we added in our Bogan character in that last episode, I thought maybe we should change it up, and now it's Zero to Bogan Zelda. That might really upset some people. I don't know. We'll see. We did say in the last episode that characters can be pretty personal and pretty important to people. Hopefully I haven't offended anyone introducing the Bogan. Well, really it's a Bogan Link, isn't it? Not Bogan Zelda. Zelda was the princess. And anyway, this lesson we will be getting the rest of our animations done for our player. At the moment all we have is the idle down, which is a little bit boring. It just means our guy sort of bops along no matter which way he's facing. So we're going to get that sorted, and we're also going to set up a camera that will follow our player around. So let's have a quick look at what we're going to be covering in this lesson, and then I'm going to talk to you a little bit about some of the aspects of Zelda that I think set it apart. So what are we doing in this lesson? Well, first up we're going to create the rest of our animations for our player so that they're fully animated, and then we're also going to create a follow cam so that we get to see our player all the time, not just when they happen to be in the right place. And why are we doing this? Well, animations give our game and our character life. They make it far more enjoyable to play a game when it's fully animated. So that's why we're doing that, to get rid of the boring. And of course, we need the camera to follow the player so we can see what we are doing. The skills you're going to need today, well, you're going to need to be able to apply the skills from our last lesson where we set up our animations, because you're going to be doing that without me for some of them. But you also need to follow along as we set up the follow cam so that you have that organized for you as well. And our success today is that you've got a fully animated character and a camera that follows them around. The golden age of arcade games was actually a little bit before my time. When I used to spend times in arcades, the games we were playing were things like Sega Rally and Daytona USA and things like that. But a bit before then, games like Pac-Man and Asteroids and things like that, Space Invaders, were all the rage. And you got to admit that by today's standards, those sorts of games leave a little bit to be desired. So back in the early 80s, games were very rigid and fixed. Every pixel was super duper important because of the low resolution. So things like Space Invaders, it really all happened on the one screen at the same time. You didn't really explore, you didn't really progress. Same like Pac-Man, the whole maze was there right in front of you. But when games started leaving the arcade and finding their way into living rooms, developers were able to change things up a little bit. The existence of save games, for example, meant that suddenly we didn't need to keep our game to a size that was conquerable within a standard setting of an arcade game. Like a couple of hours maybe, you couldn't really extend it much beyond that. Most arcade games were all about the high score as opposed to completing the game. When games like Zelda came along in the 80s though, this kind of changed. See, Zelda's world is actually only about 16 screens by 16 screens, or I think it might even be smaller, 16 by 8. And that's quite tiny, but the way they designed the world made it feel like an enormous open map that you could explore right from the start. You could choose from the very beginning of Zelda to go left, to go right, to go into a cave. It was all open. There were no instructions. You were just dumped there in the middle of a clearing and sort of expected to find your own way. But within that is actually the secret of why Zelda is such an addictive game even to this day. You see, the reason The Legend of Zelda was so incredibly successful is actually sort of hidden away in the ARPG title. See, ARPG stands for Adventure Role-Playing Game. And I want to read to you a little bit that the designer or developer of the original Legend of Zelda had to say about his design choices and the process there. And I think the secret to the success is actually hidden in what he said here. So follow along. So this is the words of Shigeru Miyamoto, who is, I guess, one of my heroes considering all the amazing things that he had a hand in there at Nintendo. Well, let's read this through and you'll see what I mean. When I was younger, I grew up in the countryside of Japan. What that meant was I spent a lot of my time playing in the rice paddies and exploring the hillsides and having fun outdoors. When I got into the upper elementary school ages, that was when I really got into hiking and mountain climbing. There was a place near Kobe where there's a mountain, and you climb the mountain, and there's a big lake near the top of it. We had gone on this hiking trip and climbed up the mountain. I was so amazed. It was the first time I had ever experienced hiking up this mountain and seeing this big lake at the top of it. I drew on that inspiration when we were working on the Legend of Zelda game, and we were creating this grand outdoor adventure where you go through these narrowed, confined spaces and come out upon this great lake. So it was around that time that I really began to start drawing on my experiences as a child and bringing that into game development. So you see, one of the key elements of an extremely successful video game franchise is actually designing it with a childlike heart, referring back to memories of childhood, how Shigeru Miyamoto created such an amazing game as The Legend of Zelda. Now, most of you watching this are still children, so hopefully you've got some first-person real-world experiences where you have experienced that sense of wonder that you can actually bring into your game development. Right? So remember, whilst you're following along with this tutorial, you are following what I am asking you to do, but what's going to set your game apart from just the boilerplate that I give you is you influencing it with your own life experiences. What are things that you enjoy? What are things that you think would become an exciting feature in your game? Don't just follow what I do. Start thinking about what you can do to make your game unique and true to yourself. And remember the words of Shigeru Miyamoto, that it was actually when he started bringing his childhood into his game development that he really became successful. And I think that's something for us to remember. So now we're going to go over into Godot and get started on our camera setup, and then we're going to do our rest of our animations, which is going to have a pretty hefty chunk of coding in there. And once we've got all of that done, you will have a player that can move all around the screen. The camera's going to follow them, and their animations are going to change depending on which way the player is currently facing. All right, we're back in Godot, and it's time to sort out our follow cam. Now, this is actually exceptionally easy, all right? So make sure you're on the world scene, which is the one that shows you the tile map. And if you remember, we dragged our player into the world scene in the last episode. So make sure you're on that. So this is what it looks like. I've got my little dude up in the corner there. There's my world map. I'm going to click on the player node in the world scene, and I'm going to right click and go add child node, and then we're going to search for the camera 2D. So you start typing in the search window and it should come up as the first thing when you start typing that in. So I'm going to hit enter, and now we've got the camera 2D attached as a child node to our player in the world scene. All right, super easy, but we need to refine it a little bit. So if we go and hit play now, something a bit annoying happens, right? So our camera is showing all of that grey space. There's no limits to it. We haven't created any limits for our camera, so it'll just go wherever our guy goes. But at the moment, our guy can walk straight off the map. We're going to change that in a later episode. We're going to set it up with some collision shapes. But for now, we also just want to limit the camera to the actual map space so that our guy can walk to the edge of the map and the camera doesn't keep going and showing the grey. It'll actually stop and the guy will sort of walk to the edge, if that makes sense. So right now it looks like this. Terrible, terrible. Let's close that down. Now, we've got over here, so as long as you've got camera 2D selected on the left hand side, you should be able to go to the inspector window, come down and click on the limit and open those up. And now you see you've got all these numbers in here, left, top, right, bottom. Big numbers too. So the left and the top are actually going to be super easy if you've done your map the same way as me. So I started my map at that origin point there, and I've only built down and to the right, which means that my left pixel can be 0 and my top pixel can be 0. So just to show you what that does, if we now hit play, the camera no longer shows that grey space, and our player can walk and it'll still follow in that direction. It'll follow here, but it'll stop at the edge so our player doesn't expose all that grey space, right? That's what we're going for there. So let's close that back down and work out how we're going to do the other two. So the other two are clearly not going to be 0, right? Because we've built a mile along. So make sure we've got our camera 2D selected. We've got our limits here. Now there is a little cheat. So there's probably a way to do this that's like perfect, but I'm not a perfectionist, right? Near enough is good enough with a lot of things, especially when we're just learning about them in the first stages. your canvas actually has a ruler around the edge that tells you how many pixels along you are. So we can just use these rulers to work out roughly where we want our camera to stop. So for our right guide, you can see we've got a 750 here and an 800 here. So probably something around 770 or 760. Actually, maybe even higher. Let's go to say 770. That works for me. And it actually has created a little guide there showing us roughly where it is. So we can actually go a bit further, go 775, or we can go further, 780. That'll do. All right, 780. But now we've still got to deal with the bottom, and we won't get that guide for the bottom. It's a little bit different, but we can still zoom in and work out what we can work out. So our bottom is between 400 and 450, probably closer to 400. So let's just go with, say, 410. I'm pretty happy with that. Now let's press play again and see if we've actually successfully got that set up. Hang on, let me just put that back on there to double check. So yours should look something like mine if you made the map the same size as mine. But if you've made your map larger or smaller, these numbers are going to need to be different. So use your rulers to make sure you're getting the right measurement for your map. We're all going to have slightly different maps, right? So that's the settings I've got there. I'm going to hit play, and hopefully we won't see any gray, so we know the camera doesn't follow us left and top. That's brilliant. We go to the bottom. Excellent. There's no gray showing, and now we're going to take the incredibly long walk to the right. We should get some music in here later, hey? And there we go. No gray. No gray anywhere on the map. Fantastic. All right. That is our follow cam sorted. Our next step is to start working on our animation. Okay, animation time. So this is going to get done a little bit differently to before. What I'm going to do is I'm going to guide you through the first one, because we've only done it once, right, in our last lesson. So I'm going to guide you through the first one, and then the rest of them, I'm actually going to just fast forward. So you're going to see it on the screen. So if you need to pause to double check what I'm doing, you can do that. Otherwise, you can just put it on fast forward, do it yourself because you got the hang of it. Once we got those animations in, then it's time for the coding. So that's what to look for. So to get started with our animations, we need to first go to our player scene, and we need to click on our animated sprite 2D. So far, all we've managed to do is get our idle down animation done, but we're actually going to have 6 animations. You might think we should have 8, but we're only going to make right-facing ones. We're not going to make left-facing ones. I'm not going to tell you why. You can have a bit of a think about how we might do that in the code. How do we turn right ones into left ones in the code? Anyway, we're only going to do the 6. So we're going to have idle down, idle up, idle right, walk down, walk up, walk right. That's it. So 6. So first thing I'm going to do is make the first one. I'm going to call it walk right. So I'm using underscores in our naming conventions here, and I want to keep that consistent. So in our code, I'll be using these exact terms. So where I've gone idle underscore down or walk underscore right, it's really important that what I put in there is the same as what I put in the code. All right, you can't have variations between those two, because in the code, we're going to specifically refer to certain animations. So make sure you put an understandable name for each of your animations, and you use the same ones in your code. Easiest way to do that is just to copy what I'm doing, all right? Anyway, we've got our walk right. If you remember how we did this, we click on the little grid pattern, we click on our bogan sprites, and then we've got to change the horizontal and vertical. If you recall, it comes up as like a 4x4 grid, because it doesn't know, right, how many sprites there are. We just change it. I think it was 5x10. There we are. So what did I say we were going to do? Walk right. So we're going to have a look here. I think our walk right is this set here, these 4 here. So I'm going to grab those ones, click add frame, and then I'm going to press play to see if that looks right. Yeah, you can see his little arms are bopping away, his legs are going back and forth. I know none of my animations and drawings and things are particularly crash hot. You are more than welcome to use your own. This is just me having a bit of a laugh, all right? So I've done the walk right. I'm now going to rapidly go through the other 4 of them. So you can either follow along with the fast forward, you can pause it, whatever works for you. All right, that's all the animations done. We've got idle down, idle right, idle up, walk down, walk right, and walk up. Hopefully you've got the same ones as me all sorted out, because if you've got the same names, it's going to make the coding a heck of a lot easier. So next thing we're going to do is head over to the code. I would say we'd go and test it, but we haven't actually changed anything, so there'd be absolutely no point in testing this. So we need to save what we've done and head over to our code now. So remember how to do that. We go to the script up the top, like that, and then that should bring up all of our code. Excellent. So we're going to now have a look at how we can change our code to allow all of our other animations to take place as well. All right, so coding time. Now, this is going to be awkward with that there. So let's just click off of Animated Sprite 2D to get rid of that from the bottom there. And here is our code from last lesson. Now, I've got a lot of changes to make to this, and I think rather than going through and typing them in line by line, I'm going to paste in the whole new bit of code. We'll talk through it all line by line. I've got a ton of comments in there, so if you don't want to listen to me, you can just, I don't know, take a screenshot of it or something and read them. But the idea is I really want you to understand what each line of code is there for, so that when you decide to make some changes to it, and I'm hoping you do later on, you will know what to change and why. Okay, so there's no point just copying it in blindly. That's not going to teach you anything. It might get your character moving, which is exciting and what we want. But the whole point of this is that you are capable of later on in this series actually going, I don't like that code, I'm going to change it. You can't change it unless you understand it, right? So let's copy in the new code and work our way through it. So here we go. Woo, look at it all. So now we've gone from like 20 odd lines to 75, but half of that is still actually comments. So back up to the top, and you will see there's a lot of things that are still the same. So we're still extending our character body 2D. We've still got our speed variable. I've still got it at 100. You may have changed it. You're welcome to do that. We are here now creating a new variable called last direction. And so that's just to keep track of which way the player has been facing, so that when we switch our animations between idle and walking, we get the right one, right? We don't want to have it walking right, and then when it stops walking right, it idles facing up or something like that. That would look weird. The guy would look slightly possessed, I think, just magically turning like that. So that's how we remember our the last way we were facing. We've then got another variable called animated sprite, and this is just to do with that animated sprite 2D that we were just playing around with, right? We need to get data from that animated sprite 2D. So we start this variable called animated sprite. Then in our function ready, we assign the animated sprite 2D to that variable that we just created. Okay, so keeping on going, we've got that physics process delta. Did any of you do the might from the last lesson and actually look that up? I hope some of you did. It's really worth the time to research some of these things so you get a better understanding of them. All right, we've got some explanations there, but that is all basically the same as last time. So from line 24 to line 35, it's basically exactly the same, right? We got physics process, we got our getting our vector based on those keys that are automatically coded, right? The up, down, left, right key on the keyboard is automatically mapped in Godot to the UI left, UI right, UI up, UI down. We've still got our velocity equals direction times speed. Keeping on scrolling. And then we get down here. So if the character is moving, so the direction is not 0, that's what the exclamation equals. So it is not 0. Update the last direction variable. So remember our last direction, where was that? Up here somewhere? Last direction, we want to update that last direction depending on the character's movement. Scrolling on down. So if direction X is not 0, the animated sprite should play walking right. So have a think about that. If it's not 0, we're walking right. So if it's 0, we're not walking, we're idling, yeah? So, but if it isn't 0, if there is any movement going on, we need to play a walking animation. So we're saying if it's not 0, if X is not 0, play walk right. Else if Y is less than 0, we're going to be walk up. So you think our Y to the sky, right? So from our Cartesian planes and things like that, X and Y to the sky. So our Y axis is the one going up and down. If that is less than 0, right, we're going to play walk up. If it's greater than 0, we play walk down. So hopefully that makes sense when you think about it in terms of those planes of movement, X and Y. And we've still got another else and that's because we need to then have our idle animations. So if our direction is greater than 0, we're going to play these ones here, which are our walking animations. But if our velocity is 0, basically, we want to do nothing. We want it to play the idle, just depending on which way we're facing will determine which idle. And if you recall, I said earlier, have a think about how we might get the right one to just become a left one without creating that animation. That's this bit here, animated sprite.flip H, flip horizontal, right? So if it's this way, we're flipping it. So that's what that bit is there. So based on the last direction. And then we've still got our move and slide. So that is our 75 lines of code. That's actually only about 15 or 20 lines of code. I will leave this bit on the screen for a little while longer, just in case you're wanting to copy that down. Then I don't think I can zoom this out, to be honest. Otherwise, I would... oh, hang on. We can pop out on the new version. I keep forgetting about things like this. The new update to Godot actually lets you pop windows out. So if you're a multi-monitor user like I am, you can just drag bits off into different screens. Now, that doesn't really help when I'm trying to record it, obviously. But yeah, there's lots of opportunities to move this around so it works for your sort of workflow. But for now, let's just, I'll scroll back up to the top. So you should have most of this. You need you need line 9 because you don't have that. You need line 13 because you don't have that. 17 and 20 you also need. But then you can skip down to line 39 and 41 and then etc. So pause this at the right spot so you can copy the code that you need to code. This is the awkward part about doing it like this, isn't it? I can't just be like, here, take the file. I mean, I probably could paste the code in somewhere, but pause it, copy it in. You actually do learn it better when you physically type it than when you just copy and paste, just saying. You're activating different parts of the brain when you're physically typing. If you really want to know how to remember something, handwriting is actually even more effective. But that's enough of a neuroscience sidetrack for right now. Handwriting code ain't going to make our player move. So get all that copied down. And then what we're going to do, we're going to test our new animations. Then we're going to wrap it up. Alright, are you ready to test to see if our animations all work? So I've just gone back into our world to the 2D view, but I'm going to come up and click on the play button, and then we're going to see. Alright, so far so good. Time to press some buttons. So down, and he starts walking down. Right, he starts walking right. Let's see if our flip H works. When I hit left, he just flips around, and you see the idle stays on the last direction they were facing. See that? Whenever I take my finger off, it stays facing that way. Now, we should still have diagonal ones, right, as well. So he sort of walks diagonally up and down. I'm really happy with how that's come out. I hope you are too. I did say in our last episode that you'll get to have a bit of control over what the character is for your game. And what I would encourage you to do, we're going to talk about this in our Must Main Mind in a minute. There's a free bit of software that you can use online in the web called Piskel. You can take that sprite strip that I gave you and you can edit it to your heart's content. If you don't like the bogan with the green thongs and the blue footy shorts and you want to change it, I have no problems with you changing that, all right? But I would recommend keeping like a backup as well, because you might do things you're like, oh no, he looks horrid, you know. So just experiment, right? You don't learn nothing unless you experiment, okay? Pretty sure Albert Einstein said something along the lines of, if you've never failed, you've never learned. So have a crack at changing up that character. You might think that this bogan does not suit your game that you've got in your mind. So I'm gonna give you some instructions on that in a moment, but don't feel bound by what I'm doing. Follow my instructions, but then use your own creative flair to make it your game, all right? So let's head on over, let's do a debrief. I'll give you your must may might for this lesson, just because there's a few things we want to do to wrap up. And then we're gonna have a look at what we're doing in the next lesson. So our must, may, might for this lesson is, well, you need to finish setting up your player animations and you need to update your code so that all those animations start working. You may like to experiment with changing your sprite using the Piskel free online pixel art editor, or you might, if you've got the time, experiment with changing the size of your map and then adjusting your camera limits. So what did we get done today? Well, we finished creating our animations, we created our follow camera, and we also updated our script to enable those animations to show. Next time, well, we're going to add collision shapes to our player and to our world to start making it so our player can actually interact better with the world around them. And the quote I would like to leave you with this week is from Albert Einstein that I referred to earlier. Here's the proper one. Anyone who has never made a mistake has never tried anything new. And I've put a little asterisk there because it might be apocryphal, but I like it anyway. See you next time.